Hello everybody, welcome to Georgia Tech. My name is Patrick Getz. I'm a graduate student here working on my PhD in electrical and computer engineering. Right now, we're in the Marcus Nanotechnology building, the Integrated Sensing Systems Lab, or iSenSys Lab, where I work under Dr. Oliver Brand. Our group primarily focuses on MEMS chemical sensors. Well, what are MEMS? MEMS are micro-electromechanical systems. There are structures that are so small you need a microscope to see them. We use these as chemical sensors, but these sensors can also be used for other applications. Today in this video, I'll be talking to you a little bit about MEMS sensors, what they are, how you can use them, and how we integrate them into our daily life. So let's get started. First off, we have to answer the question, what is a chemical sensor and what does it do? A chemical sensor can really be anything that transforms a physical property, chemical property, or any other sort of property into a measurable quantity that can be easily reported. A simple example of this is a scale. You step onto the scale and your mass or your weight, which is a physical property, gets reported to you in kilograms or pounds. Another example that you might be familiar with is a pH strip. A pH strip is something that you can dip into a solution and it will change its color based off the pH of that solution. But how do we measure things that are so small we can't even see them? What do we do in that case? We want to be able to measure the chemical composition of the air around us or the water that we drink. In our group, we use MEMS cantilevers. A cantilever is essentially a diving board. In our case, we shrink them down so they're no thicker than your hair and only a few hair widths in length. These miniature diving boards vibrate at a very, very specific frequency. If you think of going to a pool and jumping on the diving board, it's going to vibrate at a very, very specific rate. That rate is dependent on how long the diving board is, how thick it is, how wide it is, and also how much you weigh. If you think of a young child jumping on a diving board, it'll vibrate pretty quickly. As opposed to a full-grown adult jumping on the diving board, it'll vibrate slower and slower as the adult gets larger and larger. As we make our cantilevers smaller and smaller, they vibrate faster and faster and become much more sensitive to small changes in their mass. For example, the cantilevers that I make vibrate around 600,000 times every single second, and they're sensitive to picogram changes in their mass. This is 1/1,000,000th of a gram, which allows us to measure parts per million of changes in concentration of our gas solution. I prepared a simple demonstration to show how we use cantilevers as mass sensors in our lab. All we need are a couple of rulers. I have a 9-inch plastic ruler and a smaller 6-inch metal ruler. A couple of clamps. If we don't have clamps, binder clips would also work. A couple small rubber bands. And a few small household objects. I have a 20-gram small box, a 50-gram camera battery, and a 150-gram stainless steel wrench to use. So this is what we do. Well, that's all I have for you today. I hope you enjoyed the show and learned a little bit about sensors and cantilevers. So farewell from Georgia Tech. Goodbye.